Whoops. All right, guys, we are doing polar graphing part 2. I don't know how my window got so out of whack here. Yesterday we did these fun ones, or the first half of today. I don't remember if this is assigned in one day or two, and there was this little slide here that showed you all the fun things you could try to make. All right, but the second part of this lesson is a little drier. It is just taking and converting things from polars to rectangular and rectangular to polar. There's a lot of different things you can do with this. You can actually learn to graph all the conics we did with polars, but we're skipping all that for the sake of COVID, and we're just going to do ordered pairs back and forth, and that's it. What you're going to do if you have an r and a theta, to find the x and y, does this sound familiar? X equals r cosine theta and y equals r sine theta. It's the same as vectors, okay? So when you're given a polar and you want to go to rectangular, your r and theta are going to change into r cosine of theta, r sine of theta. Now, because we do most of this in radians, you are either going to be in radian mode, which we were yesterday when we were graphing this stuff, or you could use a unit circle for some of these if we have exact things that are on our unit circle. So here's an example. If you have the ordered pair 3 pi over 4, when you graphed it, you would have gone around on the circle to 3 pi over 4. And then you would have gone out 1 radius, 2, 3, and put the dot here. We're supposed to find the XY ordered pair that would get you to that same spot. And to do that, you do a radius of 3 times the cosine of 3 pi over 4, and a radius of 3 times the sine of 3 pi over 4. Well, if you grab your unit circle, did I put one in here? I did not. If you grab your unit circle, and you go to 3 pi over 4, it's negative square root of 2 over 2, positive square root of 2 over 2. So, well, that wasn't a good plan. This value is negative square root of 2 over 2, and this value is positive square root of 2 over 2. And you're supposed to multiply this by 3 and this by 3, and that'll give us our answer. So we get negative 3 square roots of 2 over 2, and this becomes positive 3 square roots of 2 over 2. All right, that was kind of messy. Let's try it again. This one is in degrees, but it's still one we can use on our unit circle. If we go to negative 60 on the unit circle, we're at 300 down here. And the ordered pair is 1/2 and negative square root of 3 over 2. So negative 60 has a cosine of 1/2 and a sine of negative square root of 3 over 2. So 20 times the cosine of negative 60 is really 20 times 1/2, or 10 is our r value. No, I'm sorry, is our x. This is r. And 20 times the sine of negative 60 gives you your y value, which is 20 times negative square root of 3 over 2. This 2 goes in here 10 times, and we get negative 10 square roots of 3. They do ask these exactly a lot of times, so you don't want to use your calculator unless you have one that's not on your unit circle. Now, it doesn't matter if you have, like I said, a negative angle or a negative r value. The plan is still the same. You're going to do negative 1 cosine 5 pi over 6 and negative 1 sine 5 pi over 6. All right, if we go to 5 pi over 6, the ordered pair is negative square root of 3 over 2, 1/2. So the x is negative square root of 3 over 2, and the y is 1/2. So when we multiply by negative 1, we just get positive square root of 3 over 2. And here we get negative 1/2. All right, let's think about that for a second, just so this makes sense to you. If you went around 5 pi over 6, and then you backed up 1 radius, you would be down in this quadrant. And it's telling you you would be the same as if you went over square root of 3 over 2 and down a negative 1/2. Okay, just so you understand why the signs are different places. All right, quickly, let's see, negative 135 would be here. The ordered pair would be negative square root of 2 over 2, negative square root of 2 over 2. So this would be 6 times the cosine value, comma 6 times the sine value, and 2 goes into 6 3 times to get negative 3 square roots of 2 both times. Number 4 says pi over 3. If you go around to pi over 3, that's here up top, and the ordered pair at pi over 3 is over 1/2 and up square root of 3 over 2. Do you want to check me? Right up here at pi over 3, we have 1/2 and square root of 3 over 2. So this is cosine and sine. So we have 3 times the cosine and 3 times the sine. And we get 3/2, comma 3 square roots of 3 over 2 as the xy. All right, so that was polar to rectangular. Now we got to go the other direction. The other direction, if we have the xy, okay, so we know we went over 3 and up 4. To find the r, we're going to use Pythagorean theorem. And to find the angle that we rotated, just like in vectors, we're going to use inverse tangent. Okay, now I think they give us a weird one first. They say we went 5 to the right and down 9. So first we do Pythagorean theorem. Square that, we get 25. Square that, we get 81 here. The square root of 106. And they said that's 10.3. So the radius here is 10.3. So our theta value starts with a 10.3. And then we need a theta back here. Degrees would work much better in our little brains, but they want us to use radians. So when we do this, we're going to leave our calculator in radians and do inverse tangent of y over x in radians. We're in radians, so we go inverse tangent. I forgot the numbers. -9 over 5. Now, we would worry about the quadrant, except in the fourth quadrant, it gives us the right answer. It says you rotate a -1.06 radians, which is correct. We went this way. So -1.06 radians. Now, if you wanted another name for that spot, an easy name would be to say I'm going to go this way, which would be 2 pi minus 1.06, which if I do that, 2 times pi minus 1.06, you could have said I'm going to go positive 2.08 radians, and my r is still going to be 10.3. Now, somewhere you have to state that it's an r theta, otherwise it looks just like an xy. All right, so find 2 pairs of polar coordinates for each of these in radians between 0 and 2 pi. This is actually one we could use a unit circle for, because if you go over 2 and down 2, You can do it in a decimal, but does anybody recognize that would be a 45 degree or a pi over 4? Okay, and then to find the length of it, remember we're using r squared equals x squared plus y squared, and then square rooting to find r, and we're using inverse tangent of y over x to find theta. So if we did Pythagorean theorem, four plus 4 is 8, which is square root of 4, square root of 2, or 2 square roots of 2. So 2 square roots of 2 is our r value. And theta, we could say theta is negative pi over 4. I will show you what the calculator will do, though. It'll give us a decimal. When we do inverse tangent of y over x, inverse tangent negative 2 over 2. Ugh, what in the world does that say? It gives us a decimal. That decimal is actually equivalent to negative pi over 4. Okay, but you can just say negative 0.79. It's fine with me. But they're supposed to give us another name. That's really not two different names. That's the same name. Another name would be to say I'm going to go this way. So that is, instead of a negative, you're going to add a whole 2 pi to that, which, if you wanted an exact answer, would be 7 pi over 4. But if you're going to do a decimal, if you had that negative 0.78, whatever it was here, and you added 2 pi to it to get a positive number, you would have 5.497 or 5.5. Which is equivalent to this 7 pi over 4, okay? You could have also given me the square root of 8 as a decimal. It's probably going to be a multiple choice question, so just figure out which one they did. 3, 5 is not a special right triangle. If you went over 3 and up 5, the only way to find r is to do Pythagorean theorem. 25 and 9 would be 34. So you're going to have square root of 34. And then to find this angle, you're going to do inverse tangent of the y over the x. Remember, y and x over here. So inverse tangent in radians of 5/3 is 1.03. Okay. Now to get another name, you could say I'm going to add half of a rotation to that, which would be pi. When you add pi to that, you get 4.17. If you rotate it around to 4.17, you'd have to back up a radius of negative square root of 34. All right. I think you have to do a couple of these on delta math, but I think they're using the unit circle. Okay. So here's some using the unit circle. This is an x and a y. So to find r, we're going to square them and add them together. This is 4. This is 2 squared is 4. Square root of 3 squared is just 3. So this is 12 plus 4 is 16. And that's r squared, so r is 4. Now, we have to figure out what angle has this in radians. If we did inverse tangent of y over x, we get the inverse tangent of square root of 3, and I think we can figure that out. The tangent is square root of 3 when you put this y over this x. So that's at pi over 3. So we have an r that's 4, and we went over pi over 3. Now we're supposed to do another name. Yes. Convert each pair to polar. Oh, give 2 possible solutions. I thought maybe we didn't have to do 2. Okay. Another way to talk about pi over 3. Let's see. We could do several things. We could subtract 2 pi and say it went negative 7 pi over 3, 5 pi over 3 that would be. Why won't this move? Okay, 5 pi over 3 is all the way except here, so you could go negative 5 pi over 3. Or you could go straight across, which is 4 pi over 3, and then back up. So we could say, I'm going to go negative 5 pi over 3 and out 4. Or you could say you're going to go 4 pi over 3, but you're going to back up 4. So those are some options. This is a 45. You see those square root of 2 over 2's? Okay. If you went 3 square roots of 2 over 2 and then down 3 square roots of 2 over 2, you're right here at a 45, 45, 90. But I'll go ahead and do the crazy business. R squared is that squared plus that squared. So when you square this, you get 9. You square the square root of 2, you get 2. You square this 2 on the bottom, you get 4. 9 times 2 over 4. This is 18 fourths plus another 18 fourths. You add the top and keep the bottom. Remember that? So you get 9. Do it on your calculator. It comes out 9. So the radius is 9. R theta is going to have a 9. And then if you do an inverse tangent, oh, this is going to be disgusting. Inverse tangent. And it was negative 3 square roots of 2. Arrow to the right, divided by 2. Oh, I forgot an extra parenthesis. Need to insert a parenthesis here because we're squaring all that. No, we're not. We're dividing it by. Oh, the same thing again. It's just negative 1, right, guys? When you divide all that, why am I doing all this? I was just trying to show you how you could type it, but this is gross. And I forgot a parenthesis in the front of that one. Insert a parenthesis, go to the back. Okay, would have been a whole lot faster to just figure out that that's negative 1. All right. So if you want to do a decimal, it's negative 0.79, which is also a negative pi over 4. But if you wanted to say I'm going to go all the way around this way, you would add 2 pi to that. And then you'd have 9. And positive 5.49. Oh, we were supposed to do these exact, weren't we? All right. Well, if you did figure out that the tangent is 1 or negative 1, that happens at negative pi over 4. So you could have had negative 9 9 and negative pi over 4, which is the same as 9 and positive 7 pi over 4. Or you could have done 5 pi over 4 negative with a negative 9 in there. All right, are we done? Oh, a couple multiple choice questions here. Negative 3, negative 3. You went left 3 and down 3. Well, most of us recognize that's a 45, okay? But otherwise, what you're supposed to do is x squared plus y squared equals r squared. This is 9 and 9 is 18. The square root of 18 is 9 times 2, so it's 3. Square root of 2 is your r. So that gets rid of this and this. And if you're in this quadrant, guys, it can't be pi over 4, okay? It's a 5 pi over 4. If you did inverse tangent of negative 3 over negative 3, you would get the wrong answer, actually. You would get pi over 4 because you have to realize that the quadrant needs you to add pi because it's going to tell you over here. Anyway, I'm not going to ask you that. Find the rectangular coordinates. Oh, this is an r and this is a theta, and it happens to be in degrees. But if we go around to 150, the ordered pair is negative square root of 3 over 2 and 1/2. So there's the cosine and the sine. So r times the cosine and r times the sine will give us the xy ordered pairs. So 4 is divisible by 2. We get negative 2 square roots of 3. And 4 times 1/2 is 2, which is choice A. Now I'm done.